Hello, welcome to another video about Unity shaders. Today, I'm going to demonstrate how to create a shader for a snow mountain. I'll be using the Universal Render Pipeline and Shader Graph for this tutorial, so make sure to have them installed before we begin. With everything set up and ready to go, let's dive right in. First, let's create the model for the mountain. You can use any modeling software of your choice. Here, I'll demonstrate using Blender. In Blender, there's a convenient add-on that can help us quickly generate the mountain model. We need to install this add-on first. Click on Edit, Preferences, then Add-ons. Search for Landscape and you'll find it. Next, delete the default cube and add a landscape to the scene. Click on Tool in the bottom left corner to access more detailed settings. By changing the seed value, we can discover the mountain terrain that you prefer. Next, let's proceed to set up the UVs for this landscape. Press U and then select Unwrap to proceed. Now we have a simple landscape model. Let's export it as an FBX file. In the export settings, remember to check Apply Transform to avoid any coordinate issues when importing the model into Unity. Let's move on to Unity now. Find an empty area in your project's scene. Then, drag and drop the mountain model into the scene and adjust it to an appropriate size. Let's move it to a spot where it's easier to observe with the camera, making it more convenient for making adjustments. Next, let's create a shader for this mountain. Choose Shader, then Universal Render Pipeline, and then Lit Shader Graph. Give this graph a name and double-click to open it. Right-click on the tab and maximize the window. Next, let's create a float parameter to control the smoothness. We also need a ground texture to give the mountain some color. Drag and drop the ground texture into the graph and connect it to the Sample Texture 2D node. Next, we need the UV coordinates for this texture. Let's create a vector 4 to represent the tiling and offset of this texture. By using the Split node, we can access the individual values of the vector 4. Next, let's combine the x and y values into a vector 2, and the z and w values into another vector 2. Then, connect them to the offset and tiling nodes. Connect it to the UV input of the texture node. Now, the texture's UV setup is complete. Connect the RGBA to the base color, then press Save Asset. Next, let's create a material and give it a name. Remember to select the shader we created for this material. Drag this material onto the mountain model. Then, choose a texture for it. Adjust the UV to ensure that the texture is correctly projected onto the model. Now the model has one texture, but it looks a bit plain. So, let's add a second ground texture to make the mountain more visually appealing. We need to create another texture and a vector 4 to control it, just like before. Select all the nodes of ground texture 1, then press Ctrl D on your keyboard to duplicate the selected nodes. Remember to switch the texture and UV to those of texture 2. Now, let's use the Lerp node to blend these two textures together. We need a factor to control the blending ratio. Let's start by using a float to test it. Now, when we increase the value to 1, the ground material will transition to the second texture. Don't forget to adjust the UV coordinates for the second texture as well. Now, when we adjust the value, the material of the entire model changes, which is not what we expected. So, let's use noise to blend these two textures instead. Right-click and search for Simple Noise. Then change the scale to 1. This noise node also has a UV input, so we need to create UV values for this noise node as well. Create a vector 4 and remove the float, as we won't need it. Let's connect the noise to the base color so we can observe the size of the noise. It seems that the UV for the noise is too small. Let's increase the tiling value of the UV to allow the noise to cover the entire mountain range. Now it looks better. Let's connect the output of the Lerp node to the base color and see the result. It doesn't look very noticeable because our texture colors are too similar. Let's try using a brighter texture and see how it looks. After completing the textures for the ground, let's create textures for the snow. First, we also need to create 2 sets of textures in Vector 4. Next, we click on the ground group, then duplicate all the nodes, and replace the texture and UV with the ones for the snow. Connect it to the base color and take a look at the result. Select the texture for the snow and adjust its size. Do the same for the second texture. And there you have it, we've completed the snow part. Next part, we need to determine which areas are snow covered and which areas are the ground. Just like in the picture, snow will cover the flatter areas of the ground, while vertical surfaces will have less snow. Therefore, we need to determine if the vertex angles of the model are relatively flat. By calculating the distance between a vertex's normal and the upward direction, we can determine whether the vertex is flat or not. So let's do this in Shader Graph. First, we need a normal vertex node to retrieve the vertex's normal. Then, connect it to a distance node. Set the b value of the distance node to 0, 1, 0, which represents the upward vector. Finally, connect the result to the base color to see the outcome. Now, the areas where the vertex angles are flatter turn black, while the areas with steeper angles appear white in color. Next, we can use the Smooth Step node to control the degree of snow coverage, allowing us to adjust it more conveniently. Click on Save and then take a look. Now we can control the range. Let's go back to the graph and use the Lerp node to blend the ground and snow. Connect the calculated vertex angle to the blending factor. It looks a bit strange because the areas of the ground and snow are reversed. Swap the connection of the ground and snow textures, and you will get the correct result. Now it is much better. Finally, let's add some details. I want to have some snow accumulation in the cracks and crevices of the ground, which will make it look more realistic. To find the areas with cracks, we can use the variation in color intensity as an indicator. Connect the result of the ground to a split node to obtain the color values. Then, connect this value to a Smooth Step node. Similarly, create a Vector 2 to control the range. This way, we can identify the cracks in the rocks. Let's see the result. Now we can adjust the values to control the range. Next, let's go back to the graph. We will add this range to the control factors of both the ground and snow. Let's move the nodes a bit to create some space. Since our snow is connected to 0, we need to use subtraction to combine them. However, if we subtract 0 from 1, the value will be less than 0. Therefore, we'll add a saturate node at the end to clamp the output between 0 and 1. Now let's adjust the range a bit. It looks like we've finally completed this shader for the snowy mountain. I hope you learned something about shaders and Unity in today's video. If this video has been helpful to you, you can hit the like button or share your comments. See you in the next video.